Now, let's look at how to plan addresses based on these principles. Let's take global unicast addresses as an example. As mentioned before, fixed prefix do not need to be planned. Only the late portion needs to be planned. During planning, some necessary information and more detailed information need to be included. Addresses are mainly categorized into three types: network addresses, user addresses, and platform addresses. Network addresses are used by network services like routers, switches, gateways, and servers. User addresses are used by individual users, like those for personal PCs, set-top boxes, and intelligent IoT terminals. Self-driving cars that may be available in the future are one of those intelligent terminals. Platform addresses are used by carriers on platforms, and other platform addresses are used by devices or servers on enterprise platforms. Let's use the previously mentioned address categorization to describe how to plan IPv6 addresses. First, let's look at the network address planning. The fixed prefix part is unchanged and does not need to be planned. A network address needs to carry a large amount of information, such as the service type, network type, and the region. As such, planning network address is relatively complex. The address category, that is, whether address is a network address, user address, or platform address, must be specified. Note that the type of user address can also be indicated by the identifier. Following the category field, a network identifier is provided to indicate whether an address belongs to a backbone network, core network, metro network, platform, or DCN. Simply put, it identifies which type of network the address belongs to. Addresses also need to carry region information. For example, addresses used by different provinces and by cooperation groups need to be specified. The parts covered so far are planned by headquarters or cooperation groups. The subsequent parts are planned by separate provinces according to their actual situations. For instance, when it comes to complex networking, both provincial backbone and metro networks are involved. We need to divide the network layers to identify whether address belongs to the provincial backbone network or metro network, or identify which metro network the address belongs to. The following part is the reserved address space that can be used internally or for future network address extension. For network slicing, a field for identifying slices needs to be planned, so that routes for a type of service can be aggregated on a slice later on. The last field is the 64-bit interface ID. To start with, we need to specify the address type. For example, whether the address is a locator address, loopback address, interface address, out-of-band NMS address, or IPv6 address for beer multicast. A metro network is usually divided into two layers, aggregation layer and access layer. Therefore, we need to specify the layer information. Then, depending on specific requirements, we can determine whether to identify device types, for example, SR, BRAS, or OLT. If this is required, we mark the information here. For the remaining space, it can be used variably by different types of addresses. Take an example. For interface interconnection addresses, the interconnection type, like upstream same level or downstream interconnection, may need to be specified. The subsequent part can be used to identify the sequence number of address. For instance, in this case of upper-level interconnection, the upper-level device may use a smaller sequence number, and the lower-level device may use a large one. For same-level interconnection, a device with a smaller ID may use smaller sequence number, and the device with a larger ID may use a large sequence number. This means this part can be used to number addresses according to customized rules. For IPv6 locator addresses, locators type need to be planned in the remaining space to cater for different application scenarios, like single homing, dual homing, or BUM. Currently, the allocated locators vary according to scenarios and need to be isolated. The following part is the locator function. Functions are classified into dynamic functions and the static functions. Finally, Argus part. When allocating function, we need to comply with preceding principles and try to aggregate the changeable parts so that SRHs can be compressed if needed. Here are some major network address planning methods. Enterprises or carriers can select the proper planning method based on their own service requirements. Next, let's look at the user addresses. Such addresses can be classified into consumption addresses, government production addresses, and IoT addresses. These addresses are used for different purposes, and therefore require varied planning. First, let's look at the consumption addresses, which are mainly used to identify a user region. To accurately identify regions, in addition to planning the address category, we need to plan the province information, the district or county ID under the province information, and other detailed information under the district or county ID. For government production addresses, ensuring service SLAs is very important. As such, we need to specify the queues information during address planning. This classifies addresses into high, medium, and low priorities. IoT addresses are classified into common and dedicated IoT addresses. Currently, IoT addresses used economically, and therefore, they do not need to be allocated to districts or counties. Instead, they only need to be allocated to provinces and can be numbered within the space at the provincial level. For dedicated APNs, different APN IDs need to be specified after addresses are allocated to the provinces. Other information can also be specified following the APN information. This sums up the allocation of user addresses. Now, let's look at platform addresses, which have a design similar to that of network addresses. Platform addresses are allocated to devices or servers on a platform and require network hierarchy. The prefix of a platform address is determined by and varies with the address allocation of the platform. Generally, a platform is connected to an upper position of a network, like provincial backbone network or metro aggregation network. Enterprises and carriers can design their own addresses that mostly closely match their requirements by referring to our design solution. That's all for this video on address planning.